Welcome to lesson 3.1, plot points in a coordinate plane. Now I know you've plotted points plenty of times before, and so you likely remember that in your parentheses when you plot a point, you have first your x coordinate, or how far left or right do you go on your x-axis, followed by your y coordinate, or how far up or down do you go, depending on your y-axis. What you might not know is that when your x and y-axis intersect, it divides up the entire coordinate plane into 4 different quadrants. And these quadrants are numbered starting in the upper right side, quadrant 1, 2, 3, and 4. For whatever reason, they never use our regular numbers for this. They always use Roman numerals in the naming of this. And because that's the way it's always been, I expect of you that when you are naming these, you will also name them using the quadrants in Roman numerals. Now, what you might be asked to do is, if there's already points that are plotted, in your homework, you might be asked to just name what the point is, or give the coordinates of the point. So like for point A, we first need our x coordinate. So going down to the x-axis would get us to a point at -3, because we're 3 to the left of our origin at 0, 0. For the y-coordinate, we can go over to the y-axis, and it's up 4. So it's then going to be a +4. You can do the same thing for b. First, we need our x-coordinate, so we can go up to our x-axis, and I figure out that b is at a +2. And then you can go left to our y-axis and find that b is at a -3. So that's one thing you might be asked to do in this lesson. Another thing you might be asked to do is plot points and then describe the location of those points. So for point A, we would first go left 4 and then up 4. So A is going to be right here. To describe your location, you can say from the origin, because you always want to say, if you're giving directions, always say where you're starting from. So from the origin, you can say left 4, up 4. You can draw arrows and point left 4, up 4. As long as you separate them by commas, I'll know what you mean, and that makes sense. You can also say it's in quadrant 2. And just make sure you say that using those Roman numerals. You can then plot B, which is at 3, -2. So 1, 2, 3, 1, 2. B is going to be right here. So you can say from origin, or you could even say 0, 0. You would go right 3 and then down 2. You can also plot, and that would be in quadrant number 4. You can also plot a point like 0, -4. So that would be at x-axis, or x-coordinate is 0, so it's going to be on the y-axis, and then it's down 4. So C is going to be right here. So you could say from the origin, or from 0, 0, you just go down 4. And it's on the y-axis, because it's not actually in a quadrant. It's on the dividing lines between the quadrants. So that'd be one way that you could describe its location as well. Other things that might happen in this section, they might give you a function or an equation, and they will restrict the domain. Now, if you remember, the domain is just asking what x values can you put into your equation. So when it says your domain is -2, -1, 0, 1, and 2, that just means that if you made a table for x and y values, it's telling you what those x values are that you're plugging in. So -2, -1, 0, 1, and 2. Now, in order to graph this, all you need to do is figure out what are the y values that go with each of those x values. And in order to do that, all you do is you take your x value and come and plug it back in to your equation. So in this case, 2 times -2 is -4, minus 1 is -5. For -1, 2 times -1 is -2, minus 1 is -3. 2 times 0 is 0, minus 1 is -1. 2 times 1 is 2, minus 1 is 1. 2 times 2 is 4, minus 1 is 3. Now, what this wanted you to do is to graph these points. So now we can go and graph that at 2, -5. we've got a point there. At -1, -3, we've got a point there. At 0, we've got a point at -1. At 1, we're going to have a point of 1. And at 2, we're going to have a point of 3. Now, what you can't do this time, do not do this, is you cannot go and draw a line. The reason being is a line implies that every point works along that line. Well, not every point works. We only actually have 5 points that exist. So these are the 5 points that would exist on our graph. And so that's all the more that we can put there. You can't connect the dots and create a line because we have restricted that domain to being only those 5 values. The last part is it wants you to identify the range. And if you remember, just like domain was the x values, the y values are your range. So you could go ahead and say that the range is -5, -3, -1, +1, and +3, because those are the y values that go with that domain. If you want to be extra fancy with it, you can also even put those in these little curly brackets, just to show that, hey, these are the numbers that go in the range. I won't require that of you, but it's the correct, nice math notation that you will see in higher levels, so it doesn't hurt to see it now. And this is a word problem that I felt that was extra fitting for this year, because it's the anniversary of the 19th Amendment being ratified, which means that women, specifically white women in the United States, were given the right to vote 100 years ago this year. And that's something that is worth celebrating. So I want to make sure I actually read this equation or this problem out loud for everyone. In 1920, the ratification of the 19th Amendment to the United States Constitution gave women the right to vote. The table shows the number to the nearest million of votes cast in presidential elections, both before and since women were able to vote. And I did provide that table for you here. First, how do you know this table is a function? Well, a function means that for every x value, there's only one y value that goes with it. So if 27 million people voted in 1920, there weren't multiple major presidential elections in 1920, there's only the one. So that means that's the only possible outcome that came from that year, and therefore it's a function because it's there's only one outcome for each input. So that's how we know it's a function. The next thing we have to do is graph the function. So I'll just do a quick little graph over here to the side, and I'll make my x values go by 4. So we'll have -4, -8, -12. I'll label that so I remember, and then 4, 8, 12. Then on the y-axis, we go from 15 up to 40. So I'll just go by tens. So 10, 20, 30, 40. And now we just have to graph this. So let's go and plot our point. So at -12, we are up at 15. -8, we were still at 15. At -4, we were up to 19. At 0, we were up to 27. At 4, we were up to 29. At 8, we were up to 37. And at 12, we were up to 40. So this is our function. Now we just need to describe any trend in the number of votes cast. Well, you can clearly see it's increasing at and after 1920, which makes sense because that literally doubled the number of people in the population who are able to vote. So going from 19 at 1916, 4 years later, that could have easily doubled and been up to 38. Clearly, it's only at 27, so not everyone is out voting yet, but there was a serious step of increase in votes that year. And by 1928, it had almost doubled from what it had been a decade earlier. So that's pretty cool. And that's it. That's the last thing in this section. So good luck. And if you have any questions, make sure you shoot me an email.